Hi, this is Meta Spencer. And boy, we're going to go someplace that I've never been to Australia and New Zealand. And I have panelists today, all of whom live in this strange part of the world. There's a dog.
That's
Whose dog is that?
Robbie's dog. We're okay now.
Okay, that was quite a welcoming. So I want to say hello to all my friends in the south part of the Pacific, in that quadrant of the globe, because we're going to talk today about nanobubbles. This is something I've been hearing about for a year or two, and just a little bit curious about how in the world bubbles are going to help save us from the climate crisis. But this is yet to be described to me. I don't know beans about nanobubbles, but these folks do, or hope that they can find out more about nanobubbles. So I'm going to introduce you all. Sev Clark is Melbourne, right? In
Yep.
Australia, or he's outside of Melbourne in the country, I gather. And it looks like he's got a terrific office there. I would love to have that much space. And Sev is very interested in, he puts a lot of stock on something called buoyant flakes, which will undoubtedly come up in this conversation, but we're really talking about nanobubbles today. And in Canberra, or someplace near there, is Robbie or Robert Tulip. And I've had a lot of conversations with Robbie before, because he and all of these guys, except for Jack, have been members for a long time of the Healthy Planet Action Coalition, which is a group of people who are extremely interested in global warming and in finding technologies that will help to cool the planet. And Robbie's own background he was trained in philosophy and then went into government and worked on development issues until he retired, and now is working very much on climate issues. And in where did you say you are, Brian? Brian von Herzen is also in Australia,
Yeah,
and
the Sunshine Coast of Queensland, Australia.
the coast. What's the biggest
Sunshine
city?
Coast. The Sunshine Coast near Brisbane.
No, Brisbane. So anyway, these guys know each other that way. And Brian is a real scientist. He has he is the president of a climate foundation.
Climate Foundation. Yeah. Executive Director at the Climate Foundation, and we focus on regenerating life in seas and soils. Thank you, Meta.
And now I get to introduce a newcomer to this group. They don't know each other so far, but I've known Jack Santa Barbara for 40 something years. And Jack is a psychologist by background, and he was a social psychologist who ran a number of offices providing services for corporations. I think, Jack, that you tell me if I'm wrong, that that corporations like to offer fringe benefits to their employees, and they could call your office and get a therapist for anybody who needed one, which I thought was wonderful service. Anyway, Jack and his wife, Joanna, who's my maybe dearest friend in the world, moved to New Zealand about, what, 15 years ago, Jack? How long ago was it?
Oh, 17 now.
17 years ago. And they live on the South Island of New Zealand in a very rural area, and do a lot of work in all of them. His son is also living there, and working on environmental issues and climate issues. So welcome, Jack. I'm glad to have you participate in this, and because you're bringing a different perspective. It's without having been part of this social bubble that the HPAC people constitute, talk to each other every day. Then you may have a different perspective and ask questions that wouldn't even occur to me to ask. So now I'm going to ask somebody to take up the topic of and explain in not 30 words or less, but many words. Sev, you put your hand up, so you have volunteered and hereby accepted. Tell us, what is this thing about nanobubbles?
Well, nanobubbles are invisibly tiny bubbles, so tiny that they are not buoyant and therefore do not burst at the sea surface. Some of you may remember how we had a green revolution that revolutionized agriculture and prevented much mass starvation last century. Well, today we have something of a different problem, an existential climate crisis. While sufficient food is again becoming a problem, global warming, extreme weather events, and mass extinctions are now our main concerns. To help address them properly enough, we need a bright revolution to re-brighten the planet, what I call a turquoise revolution, a revolution that seeks to restore the planet's reflectiveness or albedo to what it was in prehistoric times, or indeed somewhat more, in order to offset our cumulative greenhouse gas emissions.
Is that it?
Well, you wonder what nanobubbles are and what they're useful for, and that's what I'm saying they're useful for.
Okay, how does it work? That's to me the immediately interesting question. How do bubbles perform, whatever they do?
Okay. When you see bubbles in water, be it ocean foam or when you're drinking some soda, you'll notice they're reflective, they're bright, they've got a mirror-like finish. Now, if we were to generate in the sea surface, particularly that top millimetre, these non-buoyant nanobubbles, they can be made long-lived by making them attached to surfactants in that sea surface layer, and they can last for as long as months in the sea surface. And if they are, for instance, put in, say, the Gulf Stream off Africa, where the Gulf Stream begins, they could actually end up painting the entire Gulf Stream a slightly brighter colour, cooling the water, reducing the hurricanes, improving the fish, and giving us better kelp and algae and fish resources.
And coral.
And coral.
A question about that, Sev. You say the nanobubbles last for months because they're fairly stable because of their size. But why do they only last for months? What happens to them when they no longer are
eventually
available?
they'll lose their gas to the water around them. They've got protective coatings around them, if you like. Those coatings consist of, first of all, the sort of oily surfactant nanobubbles, like your detergent in your wash. Then there's the gas-saturated water. The whatever gas they have in the nanobubble gradually percolates out into the surrounding water. However, once that water is saturated, no more gas can escape. That's what helps make them stable. Stability is also helped by having ions surrounding them and actually electrical charges. But those are just subsidiary stabilizers. But eventually, like all things, the nanobubbles evaporate into the water surrounding them. But they, instead of lasting just minutes like microbubbles, or even less for larger bubbles, we can make them last for maybe 3 months in the ocean surface.
Yeah, and interpreting for Seb a little bit, bubbles in the ocean naturally survive for seconds to perhaps months. Sea foam and sea spray are examples of this. So it's very much a nature-based or nature-inspired approach. We know that sea foam is much brighter than deep, dark blue ocean, and that can help to reflect sunlight and reduce the amount of ocean warming that is unprecedented today. And I think there's open research. And when Sev talks about a detergent coating, he's actually referring to the plankton in the ocean producing biofilm organic molecules that facilitate sea foam. So this is all natural material that exists in the ocean already. The reason that sea foam forms is because of these natural compounds that algae produce and that form these surfactants naturally and produce sometimes the foam that you'll see on the beach, etc. So the question is, can we restore the plankton forests of the world and the other algae forests, like the seaweed forest behind me right now? Can we appreciate the ecosystem services that these natural forests provide? And can we recognize the important services, including producing sea foams and producing greater reflectance that could actually be part of our climate choices going forward for our locales, for our coastal communities, for our regions, and even ultimately for our island nations and beyond? Thanks.
So I'll add a few comments, please. And sorry, Chris. The 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 really interesting things about nanobubbles, it's a technology that has been in development over the last couple of decades, mainly for wastewater treatment and for various other uses. It hasn't been applied to climate change. And so the question of whether it can be is still in quite an early research state. For example, it would be really interesting to invite tourist resorts who've got coral bleaching problems to use to test nanobubbles to see if they're a cost-effective way to protect their reefs. But the thing that is particularly, if it does prove to be cost effective, then one of the great benefits of nanobubbles are that they can be used as a completely local method that is used to cool the water and protect the ecology in a way that demonstrates to the community the real high value of cooling as a climate solution. We've currently got a climate change conversation that's really dominated by the idea of emission reduction. And what our conclusion within the Healthy Planet Action Coalition community is that while emission reduction is crucially important, it's nowhere near enough to prevent climate catastrophe and collapse. And we're on the brink of the collapse of some fragile Earth systems. And so we need to do the research into the technologies that can cool the planet to bring us back from the precipice. And it may be that nanobubbles will prove a safe and acceptable entry technology that can help the broader community to understand the need for research into the whole range of other technologies that can restore planetary albedo, reflect more sunlight back to space, and give us a bit more time so that the longer term agenda of fixing the carbon problem, the greenhouse gas problem, can be solved in a practical way.
Yeah, Jennifer.
Yeah, if I can, as the person is relatively new to the whole nanobubble dynamic, I've tried to do a little bit of research and learn a bit about it. But there's some, if we could step back from the nanobubbles for a second and look at some of the broader issues involved in terms of, first of all, identifying climate change as the issue to address. And I circulated to the small group some simple statements about the climate issue being a symptom of a more basic dynamic in terms of humanity's ecological footprint. You know, just the amount of demands that we are currently making on natural sources and sinks. And we're disrupting a whole range of regional and global ecosystems at scale. And the climate situation is certainly an incredibly important one. It only accounts for it accounts for approximately 60% of the overall footprint. So that even if we were successful in dealing with the climate issue, which we're far from, I totally agree, and it needs lots of attention, there's still 40% of human impact that presents an existential crisis for us. And to me, one of the consequences of that perspective is that when we look at trying to deal with the climate issue, which we must, it's critical that we ensure we don't make any of these other issues worse, because there's so much fragility that we've created in what should be very robust Earth systems. And we risk irreversible tipping points, which we're only learning about. And there's growing research, but it's still a dearth of research about tipping points, where exactly their triggering points are and how close we are. But some of the recent evidence that I'm familiar with, at least, is that we may only be a decade or two away from some of these global system tipping points. And some of them, you know, some people argue that we may have already passed some of them. And there's, of course, the risk of them cascading. So the concern about not making any of these systems worse as we address the climate issue seems to me an incredibly important one. And I wonder if I'd be very interested in how you folks view that perspective.
I think Brian was the one who's had his hand up first.
Yeah, these are great points, Jack, and I think it's really important to reflect on that. Um, I think you've touched on the idea not only of climate disruption, but also of our ecological footprint, largely with respect to food security. Approximately a quarter of all land is presently used for farming, and it's a dramatic opposition to the natural environment. Now, our challenge is how are we going to feed 10 billion people in this century without increasing the ecological footprint? But I would actually set perhaps a higher goal, and that is how can we decrease our footprint? And thankfully, one great book by George Monbiot called Regenesis actually discusses
Mm.
one of a few technologies that works. And he described a whole bunch of technologies that don't work, but one that's very promising is actually called precision fermentation. Think of it like beer vats that are actually growing protein. And the estimates are, George estimates presently that we can feed the world with 50 times less land area than we're presently feeding the world using precision fermentation, some whole foods, let's say plants and vegetables. That combination could be quite viable and provide an order of magnitude reduction in our footprint and our impact. And our great hope from it here in Australia is that we can rewild. I'm part of the Woodford Folk Festival group. They planted 120,000 trees and turned a pasture into a subtropical rainforest again,
Mm.
thank heavens. And they did that over a period of 20 years. And this weekend is going to be the 21st or 22nd planting, which is a weekend festival where we plant thousands of trees. And this is the right time of year to do it. So here's an example. It's a hope for the future. And what we like to focus on is regenerative technology, usually either nature-based or nature-inspired, that can get us back to a sustainable planet with a smaller footprint than we had before. So my great hope is that we can rewild most of the farmland and pasture land around you and me in New Zealand and Australia, respectively, in the coming future, and address some of those 7 of 9 planetary boundaries that have been exceeded already. Thanks.
And Sev.
Jack, you mentioned the risk of these interventions. However, what you didn't mention is the certainty of climate catastrophe if we don't come up with some interventions. You've got to balance risk against risk, and this is what most of the people have not been able to do. The IPCC and whatever, they just and the environmentalists, they just look at the largely unknown risks of certain interventions. They don't balance it against the far greater risk, indeed the certainty of our demise, of our civilization, if we don't come up with some good solutions.
So to add to that, the question about these really excellent points that Jack's raised is sequencing. Like what's the most urgent problem? And I would say that the most urgent problem is heat. That is, we've got coral bleaching, we've got extreme weather, we've got biodiversity collapse, we've got these, and the main driver of these global problems is the heat from anthropogenic emissions. We're in a situation where the politics of addressing the greenhouse gases is immensely difficult. It will take a long time to get greenhouse gas levels back down to a safe level. In that context, as we ask, okay, what can we do to prevent or reduce the risk of tipping points? It's like we're standing on a precipice at risk of falling off, and we need to step back from the precipice by finding the best ways that we can to reduce the heat in the Earth system. And it may be that nanobubbles will prove to be a really good entry point to that challenge. If we can add large quantities of nanobubbles to the ocean, reflect more sunlight back to space, and protect the coral reefs from bleaching, and reduce the intensity of extreme weather, it just buys us time to address the longer term, more systemic problems around carbon dioxide, methane, and other greenhouse gases, and also to think about understanding things in a global way, just understanding the sort of systemic ecological crises that we face, and develop a sequential approach, a sequential scientific approach to solving those problems.
I have my own questions, and I'm glad you mentioned that it is albedo, because I was wondering. I still don't quite understand the mechanism by which these bubbles are supposed to function and do such good service for us. I guess then the notion is that they provide increasing albedo on the oceans, which I'm very welcome. I would welcome that. I actually believe someplace I have read recently, and one of you can probably inform me where I heard this, that in terms of the amount of heating of the planet, that about as much of the heating can be attributed to albedo as can be attributed to greenhouse gases.
There's a balance between climate forcing and climate feedbacks. And the forcing is mainly from anthropogenic emissions. But then what happens is that James Hansen, in some of his recent papers, estimated that the feedbacks, particularly from the evaporation of clouds due to higher temperature, but also loss of snow and ice and loss of aerosols, that the warming due to that over the last decade has been 4 times more than the direct forcing warming from greenhouse gases. So if we can address the feedbacks through technologies like nanobubbles, then we can reduce the temperature in a much more efficient and fast way than if we focus solely on addressing the forcing from greenhouse gas emissions. So I'll pass on to Jack.
Yeah. Well, I would certainly agree that cooling is highly desirable. There's no question about that. The question I would ask is, what are we currently doing that is reducing albedo? What are the activities that we're currently doing,
So
and what
that's
is the impact of those? I
yeah.
asked Claude, my AI assistant, about this, and they came up with a whole range of human activities that I believe I shared with you.
Mm.
In terms of things like mining, oil spills, other chemical spills, heat distribution from wastewater into the ocean. There's a whole range of things that, and of course, all of these things are growing. All of these activities are expanding, and they're currently estimated to account for at least a half a degree of reduction in albedo. So, you know, to allow these things to continue while and not putting energy into them while attempting to create new ways of cooling, I think it's a question that needs to be addressed in some empirical way. So that's one point, but there's so many issues that are
Sure.
being raised here. It's hard to keep track. But
Yeah, one at a time.
yeah,
I think
and the other point I wanted to make too, just as a general one, with respect to the biosphere. Again, this is kind of taking a wide boundary perspective on this issue, but I think it's important that we think in terms of the biosphere being a fairly unique galactic phenomenon. It's the only one we know of. And from an ethical perspective, Rob, it seems to me that one of the imperatives is that we protect it, and do what we can. But recognizing the complexity of the biosphere and its self-regulating capacities, and the fact that it's the only system we know of that recycles 100% of the materials that it uses. It has, if to anthropomorphize a bit, it has a wisdom that none of us collectively yet have anything close to. The history of evolution of the biosphere is increasing complexity, increasing biodiversity, and it's the way of fighting entropy, if you will. So interfering with that natural regenerative processes of both sources and sinks, regenerating both, and maintaining that balance and maintaining that wide boundary perspective in terms of everything that's being done is in the interest of increased biodiversity and complexity. My concern is that if we interfere with that, we're likely to do more damage because there's so many unknowns that
So
we're
the problem, Jack, is that we are interfering on absolutely massive scale. 2.5 trillion tonnes of carbon dioxide has been dumped into the atmosphere by industrial civilization, and that scale of poisoning requires some sort of antidote before the patient dies. So the homeostasis of Gaia, what you're referring to as the systemic nature of the Earth, is under immense threat. And so we need to find ways to find a tourniquet that can stabilise the patient while we develop longer-term systemic questions. But the politics around this are equally toxic. We've found that the idea that we should restore albedo, and over the last decade or so, the world is getting darker. Like not just politically, not just culturally, but physically darker. We're in this collapse of albedo. And you ask, what are we doing about it? Well, we're going in the exact opposite direction. The International Maritime Organization removed sulfur from shipping fuels, and that's caused possibly a 1 degree spike in temperature over the last couple of years. People seem not to be aware or care about albedo as the primary driver of heat, the primary feedback process from our emissions. So we've got to generate this awareness. And then the question is, what are the first technologies that can be used to restore albedo, to remove this dangerous heat? And part of the problem is, like, the debate tends to get dominated by these global technologies like stratospheric aerosol injection, which are really they've generated a lot of fear and concern in the community, and it's very difficult to get the social acceptance, the permission, the license to operate for those sorts of global technologies. So we need to start with things that are safe, small, local, acceptable. Brian's doing some superb work in his marine permaculture in these sort of local acceptable ways, and we hope that nanobubbles can be another example, because it's just air. It's not plastic. It's not sulfur. It's not iron. All of the but starting with technologies that are safe and acceptable can be an entry point to prevent the tipping points.
Well, I totally agree with you about the severity, the magnitude of the challenge, and the fact that we're disrupting things at an incredible scale and pace. But I would suggest a slightly different take on it in terms of prioritizing the termination of the bad things we're doing. And I know politically it's a very difficult task, but if we have clarity about what's necessary in terms of maintaining and restoring the biosphere, it seems to me that, for example, rationing fossil fuels would provide certainty about emissions.
It's a great idea, Jack, but it's just really impossible in a democratic political environment where people just love burning petrol.
I appreciate that, but part of the reason they love it is not only because it's convenient and fun, but because they don't understand the consequences. You've made several references to helping people understand the severity of the situation we have. And I think it's a big challenge. I don't have answers about how to do that. Don't want to pretend to, but I'm suggesting that more effort and brainstorming and creative thinking about how to do that may help people and decision makers. And, one of the reasons I was so excited about the actuaries' work with the earth scientist from the University of Exeter,
the Climate Scorpion report.
Hey?
Climate Scorpion. The sting is in the tail of global warming.
Yeah. But they went way beyond global warming. They were dealing with a whole range of what they call systemic risks. And the thing that encouraged me so much about it is that actuaries are one of the most, conservative groups you can think of. I mean, they're all math nerds, but inherent in their methodology is a focus on worst case scenarios so that they can be avoided. And they have a methodology for dealing with that uncertainty, but they also have the ear of CEOs and the ear of boards of directors and the ears of politicians and treasury board people. And if that message that we share a concern about the magnitude and scale of the challenges that we face.
Yeah,
If those actuaries can start making inroads into those circles of decision makers about how grossly underestimating risks things like the IPCC and even the biodiversity panel have. They're grossly underestimating the risks, according to the actuaries,
that is correct.
because they're looking at risks in a siloed way. They're not looking at the systemic risk and how these various sectors are impacting each other in terms of magnifying the risks. And that's why they're grossly underestimated. So, I
So,
mean, there may be some social tipping points here, I guess is what I'm
absolutely.
maybe hoping for or implying that, if we can help people get these messages and appreciate two things, I think. One is the seriousness of the problem, because fear is a motivator. I mean, none of us would be here today if our ancestors didn't have good fear responses and know how to act to them. So we shouldn't be afraid of giving the difficult messages. But I think the second thing that the environmental movement is not doing well at all is pointing out that what, and this is where my social psych comes in, pointing out that the factors that contribute the most to human life satisfaction are not material possessions. There's there are things like identity, voice in community, role in community, leisure time. Those are the things that really make a difference in terms of well-being. We haven't gotten that message out very well. We don't know how to do it. We're academics. We're not. I think the arts community has to be brought in to help a broader part of the public come to understand and appreciate where where the really important things in life are all about. And
Brian
if
had his hand up a long time ago. Brian, you
say,
turned.
say again.
Okay, Jack, I'm glad that you raised the actuaries reports, the International Association of Actuaries, and they've given up on 1.5 to 2 degrees of warming. They're saying, we've already got 3 to 4 degrees of warming
Mm.
in that pipeline, closer to three. Maybe they're saying above two and at least three. James Hansen has followed up with 3.6 to 6 degrees Celsius of warming just based on the emissions so far and the long tail of the scorpion. So these are really essential. I think I agree with you that we need to get the messages out and drive for social change. You asked earlier well, um, about why the Earth is dimmer than it was, let's say 20 years ago or 60 years ago. And this data is actually coming from NASA and their studies and the NASA Sirius satellite and also the Big Bear Solar Observatory. What they found empirically is that we've lost about 0.5% of the reflectance of ocean planet Earth in
Mm.
the last 20 years. Now, how did they measure that? They looked at the dark side of the moon, when you have a new moon, and they looked at the Earth glow. And the Big Bear Solar Observatory measured the Earth, the amount of light glowing, reflecting off the moon's surface and coming back to the Earth. And they actually were able to measure a 0.5% decrease. Now, what has caused this decrease is largely a loss of marine clouds and a loss of sea ice. And the sea ice we talked about separately with Sev earlier today. But the marine clouds are really essential because just in the last 12 months, some NASA scientists have published their study of marine clouds as a function of latitude and ocean over the past, let's see, it was 40 years of satellite observations. And they documented the decrease in the intertropical convergence zone in the Pacific and its almost elimination in the Atlantic, which has resulted in amazing increase in warming in those tropical regions. And the other thing they documented was a poleward migration of the boundary from the clear subtropics to the cloudy temperate regions. So those boundaries are moving towards the poles as the Earth is getting warmer. And that combined effect, I believe the marine clouds are the majority of this dimming effect. And this loss of marine clouds we see as really essential. Now, bubbles fit in because anytime you have sea spray, you've got white caps and whatnot. As we know, the white caps are white and the ocean's dark blue, and so that actually represents a difference. And when there are sea foams, they're a lot closer to white than the clouds are themselves. So we think that a combination of marine cloud rebrightening and possibly using ship tracks, which have become a lot dimmer recently, and also contribute to clouds. Even though the all those sulfur aerosols have been canceled, there is a chance to maybe rebrighten the ship tracks using things like microbubbles and nanobubbles in the future. And we'll have to research how long they last and research what can be done at the scale of a ship, etc. But this is one of several approaches to rebrighten our planet in a timely way. And I think that's a key opportunity. We've got three legs to the climate triad for us to just get out of this mess, and that is emissions to zero. And this is no excuse for continuing fossil fuels. Emissions have to go to zero. We've got something on the order of 2,400 gigatons of carbon removal that's needed, but it's going to take so many decades now for us to dig ourselves out of the hole that we've created that some levels of nature-based or nature-inspired climate repair may be needed to keep our ecosystem within the planetary boundaries while we're getting our carbon budget back into balance. At least that's our hope.
It really will be needed because one of the problems is that as the world warms, these feedback processes, like the evaporation of clouds, are just causing even more greenhouse gases, like the release of methane from wetlands. We've just got to physically cool the planet and find the most safe and acceptable initial ways to do that, to just change the conversation and bring this problem of global thinking of Earth systems into the public debate. At the moment, these sorts of conversations that Meta so wonderfully convenes don't get into the mass media. That it needs to be introduced into mass media in a constructive, scientific, rigorous way, so that the security dimension, like with the Climate Scorpion report from the UK Institute of Actuaries, they say that their key takeout is that our planet is insolvent, and when you're financially bankrupt, it's a really big problem. But when the planet goes insolvent, it's an economic, a social collapse. We need to find ways to prevent collapse and help us to work through the longer term ecological challenges that we face.
Now, I again agree with much of that. The point, 2 points though. One is it's essential that we stop doing the bad things, and support for rationing of fossil fuels. I don't know if you folks are familiar with David Fleming's tradable energy quota approach. Fleming was a UK economist, I think maybe about 30 years ago, and he developed what he called tradable energy quota system, and it sets a limit on the amount of fossil fuels that can be made available for use, and decreases that amount every year over a given time span. So it guarantees reduced emissions over time. And it's the only system I know of, other than, these market-based systems are not working currently, the ETSs and so on. So rationing to me is the only certain way of reducing emissions, which would also, because it would reduce economic activity, which is the problem, it would also indirectly reduce biogenic emissions, just because the level of activity provided by fossil fuels would decline. So to me, that would be a key factor in trying to reduce the heating that we're doing, as well as a whole range of other environmental destruction. And if we don't reduce the destruction, it seems to me that no amount of attempts to somehow fix things faster than we're destroying them simply isn't going to work.
Just have a
We're
real
already
problem.
way past that.
I don't know why you don't do everything all at once. I mean, why do
Sorry?
you think we have to reduce first and then do something else? I don't get that. I mean, if we're in an emergency, and I've listened to people making pitches, not just for nanobubbles, but, like at least 10 or 12, maybe 20 other different possible technologies that may or may not be useful. And I think myself, if I'm in an emergency, I want to do everything I can all at once, everything immediately, but not as much as possible. I think, yes, there may be some dangers, and we don't have time to check out the dangers. There isn't time to do all of that research. So what we have to do is what I would do and you would do when coming to you're thinking of diving into a pond that you haven't ever been into before. Well, for sure, you're going to stick your toe in first, and then maybe your ankle, and then you might dive in gradually. But that's what I would do. I would start experimenting with all 20 of these different possibilities, and then see if we get some bad effects. And empirically, if we find no, that wasn't a good idea because look at what's happening to your phytoplankton or your corals or something, then you stop right then. But then you got 20 other things that you're going on doing at the same time. To me, that's the rational solution. We've got an emergency, so let's do what we can by immediately experimenting with everything we've got.
I like that so very much to experiment with the things. Jack, regarding reducing emissions, all well and good, but that does nothing to address the cumulative emissions we've done over the past 10,000 years. And with that, that's enough to kill us without anything else. So we've got to do, yes, we need to reduce emissions, but you're not going to persuade people to not heat their homes very quickly. It's going to take many decades before we can get things down to zero emissions. What we've got to do right away is to cool the stuff down, to give us time to do these other things. That's what nanobubbles and these other things will do, the other things Meta was mentioning about.
And looking at that research question, there was a major scientific paper a couple of years ago that looked at the economics, and it said if the governments of the world and industries invested around $2 billion in researching the best cooling technologies, then that would avoid damage that is estimated at a cost of $10 trillion, like 5,000 to 1, which is a really important number for the benefit cost ratio. That is, we've urgently got to do the research into technologies like nanobubbles and many others. My feeling, just based on following it for a while, is that nanobubbles could be the most effective entry technology, but I don't know. It's something that just needs a lot more scientific and engineering research to test whether these estimates are correct.
It's not actually all that much research which needs to be done. With just probably a few $1 million and 2 or 3 years, we would have the answers. So it's not a huge amount. It just needs to be done, and quickly.
Well, can I
what
ask?
has actually been done? I want to know, have people done any experiments? Do they know how much it would cost to do this, whether it's feasible, all the practical things, like how would you do this? You go along with a spray gun over and spray the ocean, or how, the technology itself is completely obscure to me.
Well,
What do
we've
you
done
know can be done, and
Yeah,
what
we've
would
done
it,
phased research programs, and you've got examples of bubblers in everything from water treatment for wastewater to other applications like reoxygenation. Lake Merritt went anoxic, and they had to introduce bubblers. So we already have bubblers. There are some micro bubblers and nano bubblers that are out there. We've conducted multi-million dollar research programs that enable and show the ability to regenerate ecosystems like the kelp forest depicted behind me, and those ecosystem services are vital. So the staged research approach can be done. The technologies are there. Seb's correct that with a few million, that a lot can be done. And sadly, there's almost $0 for conducting this research. And if there's one thing, I'm going to quote some of my colleagues who said, "Look, we don't know to what extent society is going to eliminate emissions, and we do know how long it can take, and we know how long it can take to do gigatons of carbon removal from personal experience. But what we can say with certainty is that some politician sometime is going to be under pressure from his voters or her voters to do something about the unprecedented warming. And they're going to try one of these, and either we've researched it ahead of time or we haven't. And so that 2 billion that Robbie mentioned is going to save trillions of dollars potentially in climate damage for society and civilization and for ecosystems. And the question is, can we get people to wake up in time to fund some of this research so we'll know what the consequences are before some politician goes and does it unilaterally?
I would certainly support research on nanobubbles. It's not against nanobubbles. I mean, there's a lot of unknowns about them, and the material that I sent around in terms of the little bit of research I did identified a whole range of issues where the potential impact of nanobubbles might be negative on marine ecosystems. I mean,
But they didn't show anything about cooling. There was nothing in that about global cooling. So you missed
yeah,
the main point simply because AI didn't have the literature to know that this was the main point. So that some of the concerns were good, but it missed the main issue.
yeah, no, but it's a balance, isn't it, Sev, in terms of the effects of cooling and the potential negative effects. The point I'm wanting to make about the research is that it seems to me that given the complexity of the ocean system, the marine biosphere, which is the origin of all life forms on our planet, it's really an ocean world rather than a terrestrial world that we live on. And the complexities there are things that we still don't understand. So there's the known risks, but there's also unknown risks. So we would have to proceed very cautiously to not make things worse. And that could take a considerable amount of time. And again,
With nanobubbles.
pardon?
Nanobubbles can be done, nanobubbles research can be done within 2 years with a small budget.
Gosh, I mean,
Buoyant flakes research, which is the other part of the nanobubbles, is being done at the moment by 5 research agencies around the world, including 2 from the global south. They're getting very prospective results. So these researchers
can I
do not
ask you
take a lot
more?
of time,
I'd like to
and
ask you
they
more
can be
about,
done fast.
I'd like to ask you more about that, Seth, because how much of this work is being done in the open ocean as opposed to a lab or a water treatment area?
University of Hawaii is doing it. The Indian government is doing it off Goa. The USC is doing trials. University of Cape Town is planning trials. So quite a
These are
lot.
all in open ocean, are they?
A mixture of experimental work on land, on mesocosm trials in the open ocean, and then small trials in the true open ocean.
And how comprehensive is the impact on the ocean biosphere? I mean, the little bit of research I was able to do indicated there's a whole range of things from gas exchanges and potential impact on cloud formation to, marine life and the, microbial layer, which I didn't even know about, which is an interesting thing to learn about. And the fragility and complexity of that layer. I mean, it seems to me that the important issue here is how comprehensive that research is
Yeah. So,
in order
answer
to
your
make sure
question.
we're not going to making things worse.
In a related field of marine permaculture, we are now in the process of completing the second year of a 2-year carbon cycling study underneath our marine permaculture platforms. And we've developed a collaboration with Princeton, Rutgers, Scripps Institution of Oceanography, and the National Taiwan University to measure the carbon cycling and also the ecosystem ramifications for the availability of deep nutrients using a deep cycling approach. Now, it's not bubbles per se, but we have direct personal experience doing these studies that look at the autotrophy, the production, primary production, and the heterotrophy, and that is the fish that eat, and the zooplankton that eat the autotrophs, the photosynthesizers, and that multi-trophic study is presently underway. This is the kind of research that we would like to do, but
Mm,
presently, there's been zero funding for any kind of climate repair strategies, the exception being now one or two efforts in the UK and maybe one or two other places. But in many ways, we may need to turn to the global south to really lead the way. And I see our role is in helping to create a menu of choices that individual municipalities, locales, regions, islands and state and federal governments can choose from that menu what they want to do, but we have to research it and we need to get that support going in this dire time where research is being cut right and left. We need to really develop the private and public research funds that can enable these solutions to be put on the menu with known results and known side effects that we can characterize in the research that we do, and in the lab, on the mesocosm on the sea in a small scale in a box, and ultimately at small trials. I mean, we're doing a half an acre right now of seaweed regeneration, and we think the sustainable village scale will be 1 hectare, and we'd love to replicate that 1 hectare 1,000 times, but we'll do it gradually, and that's essential. I think it's really important for us to recognize the shoulders of giants that we're standing on. For example, Jacques Cousteau and 170 world leaders gathered in Rio de Janeiro in 1992 and wrote the Rio Declaration. And I think what they said in section 15 is really prophetic. They said, do not let scientific uncertainty be a cause for inaction. And for us, the inaction is researching it now so that our political leaders and municipalities will be able to make wise climate choices in the future years when things get really desperate. Thank you.
So this work that we're discussing is a great source, in my view, of hope and optimism that we can overcome the despair that people very rightly feel about the trajectory that our planet is on. Because my study of the science in this whole field of rebrightening the planet indicates that the benefits will absolutely vastly outweigh any potential damaging side effects. But it all needs the scientific research, and it can't. Our leaders have been fobbing off these assessments of benefits. The potential for example, artificial intelligence to optimize the combination of technologies that can improve our planetary climate is really immense. And as Seb mentioned earlier, we had the green revolution delivering the cereal yields that have that have prevented mass starvation over the last 50 years. We do need what Sev's called a turquoise revolution, the ability to regenerate the world ocean, to increase ocean biomass through a range of technologies is just going to be so central to protecting biodiversity, to stopping to mitigating extreme weather, to slowing sea level rise, which is just a great security crisis that all of the coastal regions of the world are facing. It's just essential that we restore the planetary albedo to address all of these direct problems, but then there's also the systemic disruptions of tipping points where we just don't know, how fast is Greenland going to melt? How fast, what's happening with Antarctica? What's happening with the Amazon? We need to protect all of these ecosystems, and the big thing that's really destroying them, it's like, sure, the forcing is from our anthropogenic emissions, but the main heat cause is the feedbacks from the darkening of the planet. So we've got to re-brighten the planet as a real urgent priority.
Okay, this is wonderful. We're very close to the end, and I think Sev probably should have the last word because everybody else has spoken lately. Sev, do you have some concluding thoughts?
Well, I'm actually quite optimistic that there are nature-based solutions which can be shown to be safe and affordable and pretty quick. And if we can get these, what's most important about these is that it doesn't threaten any existing powerful interest group. It can be done fairly economically without huge sacrifice by peoples or governments, and it can be done in such a way that if we do it gradually from small community experiments, we can gradually build up a social acceptance that many of these things are basically all to the good and should be done and can be done by communities all around the world and then up to nation states and NGOs and whatever. So I'm really chuffed that we can do this. It's simply a matter of getting the word out, getting that initial research funding, and getting the startups or existing industries to say, hey, we can do this and show that we are becoming good global citizens of the ecology and the economy. Thank you.
That's wonderful. Yeah, I'll take all the optimism I can hear. And I think we've used up every minute of our time. But the admonition that we need to get the word out is one that I take very seriously. So I hope that all of you will share this with as many people as you can get to watch it, because that's how we're going to get the word out. Anyway, time is up, and I've had a good time, and I hope you have too. So thank you all, and see you again. Okay?
Thank you, Meta.
Bye-bye.